5G fixed wireless access study on the UK. And I think we're going to talk about how 5G can help at least the cable industry, if not others as well. Now, this is being given by Jeroen Buijs. I hope I pronounced your name correctly. Jeroen is responsible for Ericsson's pre-sales activities and technology leadership, sorry, I'm croaking, in the Netherlands across all technologies and solutions. Developments such as UMTS, LTE, and various media solutions are part of your involvement. Having worked in many different fixed, mobile and cable operators across Europe, Jeroen has worked in a variety of roles and management positions inside Ericsson. Where he started his career as a software engineer, Ericsson is bridging the fixed and mobile divide to create more opportunities to enable Dutch service providers to leverage technologies such as 5G, IoT, to create additional business and volume. So, Jeroen?
Thank you. Thank you very much. And thank you for the opportunity to present about fixed wireless access. So this Dutch thing, maybe I should say a few words about that. We work a lot with Liberty Global, being of course pan-European there, and they are headquartered the CTO office in Amsterdam, and hence inside the Ericsson organization. Basically, we run it out of the Dutch organization, but it's basically across Europe. It's sad cable experience, that's quite limited, so it was very useful to listen to Paul and get a lecture on how it all started. I started off in PSTN telephony and then quickly moved into cellular networks, so I never had any view of DOCSIS, symmetrical, remote PHY, all those things, so it was very useful in the last year to work with cable service providers and now having this lecture. So what we want to discuss, I think, is with 5G around the corner, we should revisit fixed wireless access. It's not a new topic. I think it has been around many years and been discussed in 3G. It has been discussed in 4G, and of course there's many proprietary technologies that address this. I would like to say a few words on where we are on 5G. So around the corner, I think US a bit more advanced. Then revisit fixed wireless access as a topic. It's quite wide as a technology, so how do you use it, where do you use it, and how does it really complement the cable networks? Then a few words on CPEs, because this is a rather specific topic, and there I brought my friend Peter Lewis, who works at Netcom Wireless. It's our CPE partner in Ericsson. And I would like to zoom into a case that we did on Test Valley in the UK to understand how the modeling would look like if you would apply the various technologies that are coming up now. Let's start here, 5G, as a kind of a successor to 2G, 3G, 4G. I think 2G was all about voice, 3G we started to see the first data services, and 4G was really developed, I guess, for smartphones. But everything was developed for people communicating one-on-one with the cellular network with a device in hand. I think 5G is much broader. We see a large variety of use cases, so we are stretching basically the technology capabilities of the networks. We're pushing the requirements to the limits of what, I guess, technology can do today. In Ericsson, we like to say that there's typically 4 categories of use cases inside 5G. I think the easiest or the most straightforward one is mobile broadband, which is basically 4G, but with much higher data volumes, much higher throughput speeds. So, but in a sense, technology-wise, a little bit more of the same stuff. Where we stretch the limits when it comes to, for instance, low latency, massive machine-type communication. This is more about volumes. Critical machine-type communication is where, for instance, Industry 4.0 is very much interested to adopt 5G as an access technology for the plain reason that it will have a reliable connection with ultra-low latency. The trials that we're doing, everything is around 1 to 3 milliseconds in the radio path. And that will allow them to basically remove cables from operations technologies like PLC, SCADA systems, and it will allow them to create much more flexible manufacturing plants. Massive MTC, it's all about IoT, the billions of devices that we need to serve. So I think in 5G we are looking at hundreds of thousands of devices that could theoretically go into small areas with a couple of radio base stations at very low energy, very low throughputs, and hence at a very low cost. The case that we're looking into, obviously, then fixed wireless access. What we have always seen, actually it started in 3G already. We can connect the unconnected ones through 3G technology. At the time, I think there was a bit of an imbalance between the speeds that could be delivered against maybe the needs and the requirements from the end users. Television didn't really fit on there. With 4G, it's getting much better. So fixed wireless access actually will work from a 4G basis as well. But 5G will give such a dramatic capacity increase that it will improve the case, also financially. Yeah, fixed broadband, I think this is where you guys all know much better. But I think the main reason for putting up this slide is, of course, that we're going to talk about where to deploy fixed wireless access. Typically, I think ideally we go to fiber everywhere, but then we have these existing networks that can be leveraged to far extent to much higher speeds than that they are today. Both copper and cable, of course, yeah, if present, increase the capacity of those networks to their maximum capacity. Copper is a bit more difficult. I think there we see a bit of an end in the growth of the speed, so it reaches the limitations, and I think those limitations might not cater for the end user speeds needed. It could be complemented also with a fixed wireless access connection, creating a hybrid access connection. If we look a little bit at the global picture, and this is a bit how the 5G standardization world, of course, works. We look at the entire picture and we try to see, like, where would fixed wireless access really sit? Right now, and Europe, of course, is much better off, but 50% unconnected can typically be, I think, divided into those three segments. What we see in the picture is that half of the households have to some extent access to a fixed connectivity, broadband connectivity. 3G penetration is quite high and still growing. 4G will follow shortly, but as we see some large parts of the world, we're still deploying 3G for the reason that UE chipsets, handsets are still more common and more affordable for those low ARPU areas. 5G will start. First commercial live networks in the US end of this year. More volume to come next year, and then the first commercial offerings in Europe also next year. Volume rollouts expected 2020. The segment that I would like to discuss a little bit today is this one, built with precision. The next slide shows what it is about. Connect the unconnected basically is where there's no connection at all, no access to any broadband service. Not so relevant in Europe, maybe. Here you see the same three segments, but they've been, the order has been changed for the reason that we see an increase in the speed basically from left to right. So the unconnected, everything 10 megabit would be great. I mean, it gives you all the services, it gives you all the capabilities, but there is certain limitations. I think what would be a commercial offering that works for Europe is this built with precision segment, as we call this, with data rates between 50 to 200 megabit per second, maybe slightly below 50. It depends a bit on the spectrum situation in country, whether you can achieve that at first hand or not. Wireless fiber, that's the true 5G case, where we can reach those speeds of a gigabit per second to households. This is what, for instance, Verizon in the US is trialing at the end of the presentation. There's a slide on what they have done and what they have achieved so far in that. I think most interest in Europe sits really in this segment to see how you can serve the hamlets, small villages, the remote areas, rural. So let's have a look at that. A reminder of speeds, but I think in DOCSIS everybody is quite spoiled with very high data rates. But if you're underconnected, underserved today, I think you would probably like to see a couple of those HD channels plus a decent amount of internet. So if we start to model the case for suburban, we basically assume those speeds, and then we look at these offerings up to 200 megabit per second, which would be decent service levels. This got stuck. Let's go back. Sneak preview. Is fixed wireless access completely new? I think in Europe we see a few things like unlimited data bundles. So you could do tethering on your mobile, and you would have with a Wi-Fi device inside, and you could serve a couple of other devices in the home that don't have a SIM card, for instance. You could have these nomadic indoor devices, MiFi devices, that also give you access to the cellular services, but they typically come with mobile-oriented price plans. So there's caps, there's volume caps. It will not completely replace an offering for a typical household. So fixed wireless access should be about subscriptions that are a bit inspired on fixed price plans. And there could still be things like fair use policies in there, but for an end user it should behave the same way as a fixed broadband subscription should work and feel. And typically it comes with also managed CPEs, both indoor, outdoor. Peter will talk more about that in a bit. So how can we now all of a sudden, how can we now create much better service levels? We start to see a huge increase in spectrum availability in the mobile networks. In general, basically, you could apply all that to the mobile networks. You could also decide, and it depends on the regulatory situation, of course, apply for local licenses and local spectrum to do greenfield installations just for fixed wireless access. Going through these bands a little bit, GSM 3G has all been built on these 800, 900 megahertz bands. I learned about leaking ME tops today. Yeah. So in the 800 band we actually see also leaking coax devices. We see them as kind of uplink interferers in the radio base stations of the LTE networks. So they do coexist in the same frequency bands. The way it has evolved in LTE, the way those speeds have increased is by adding those mid bands, the 1800 megahertz, 2100 megahertz. Those pieces of spectrum have come to the networks, and they are basically aggregated to those high-speed data services to mobile subscriptions. And now the new chunks of spectrum, they're quite big. 3.5 gigahertz. There is 400 megahertz of spectrum typically there. Sometimes 600, can be even wider. And then when we go up to millimeter wave, kind of the 5G bands for beamforming, there's 800 megahertz of spectrum contiguous available to deploy cellular technology on. So it's a huge uptake, and that causes also that creates the capacity increase that we see in the networks. The color coding here is quite interesting. It typically depicts a bit what the mobile operators will do if they acquire the spectrum. They will at some point terminate technologies. What we see now is 3G will probably die out before 2G. Important reason there is that on 2G sit an awful lot of machine-to-machine devices, GPRS powered, with long-lasting service contracts, difficult to replace. So there's a business reason to keep GSM going. 3G doesn't create much value over 4G. Actually, 4G completely replaces that, so 3G will be terminated at some point in time. Operators that have gone public on this, they typically say 2020, 2021 or so. These networks then can be software tuned to either 4G or 5G moving forward. So what you will see is that it will all be basically 4G capacity, and over time more and more resources will be allocated to 5G. So you can dynamically allocate the spectrum in the most efficient way with the uptake of the handsets in the market and the availability of the chipsets. Those very high bands will become available for 5G only, as there's a lot of 5G technology in there. In many countries, this spectrum will be nationally licensed, so one party will get access to pieces of that spectrum and will then deploy that primarily in those dense urban environments. So that spectrum remains a little bit undeployed in those urban areas, and this is where the big opportunity lies, especially for fixed mobile converged operators, to actually use this and create a fixed wireless access subscription in those areas, offering in those areas where actually the DOCSIS networks are not present. For the incumbent PTTs with copper networks, it's a bit the same thing, although these networks stretch a bit further out. So it's a different kind of cost exercise comparing pushing the VDSL further out to maybe deploying something on a mobile network. And what we also see in countries where there is a regional licensing schedule is that greenfield companies start to develop a new network which basically only serves specific villages or so. Capacity-wise, what we tend to see is that with 3G, 4G mobile operators, if you look at their EBITDA and so on, they're suffering quite a bit with the data growth to keep up growing the networks and building the capacity. Through this massive new spectrum that becomes available, but also because of new technologies, actually this cost per bit will go down dramatically, which brings it much closer to maybe the cost of deploying a fiber case, which then might be extended over 30 years. So I've got a few slides on those technologies, how they help to decrease the cost per bit. First of all, the 5G technology will introduce beamforming. It's been discussed for a long time. In 4G we've seen massive MIMO technology, but now 5G is really all about beamforming, trying to channel the energy towards the end user, and that will give you a lot of benefits. The high frequencies will have a much lower path as a result of the worse propagation of the millimeter wave. If you can overcome this by pointing the energy more towards the UE, you can actually create that path loss, or you can reduce that path loss and create more distance. Especially for the fixed wireless access case, this is of course important as we are talking about these suburban areas, light urban areas, rural, where the distances typically tend to be longer. It brings another big benefit, and this is that without beamforming, actually all those simultaneous users are causing interference to each other, and we can now separate out the interference of the various users. So if we can do beamforming to this guy here, it will not interfere the second household. This is another connection. It will run at the same time, but the interference is not noticed at the receiver here on the uplink side of the radio. Important to get that to work. So this is the simultaneous usage that we can do to the various homes there. Capacity improvement, it's a bit of a difficult picture, but in general we say that this beamforming will give you a kind of 5 to 7 times improvement of the capacity in the cell if you're able to spread out over the various users. If you think fixed wireless access, mobile networks are built for mobility, so these UEs are a bit unpredictable. The end users, they can be everywhere, they move around, they move between cells, they drive on highways at high speed. Fixed wireless access in that sense is much easier for radio planners. The devices are static. The typical usage is known, so it's much easier to build a radio plan that holds and lasts also when you increase the utilization and the data rates. At the same time, if you create a static environment, you should also consider that over time, if you need to densify because of additional households being connected, that you might want to rework that plan. Not sure if we say something about that. We can, I guess. CPE, let's look at CPEs for a while. I'm just thinking that Ericsson builds these networks. We have sold phones, Sony Ericsson phones in the past. We stopped that because in the end you need an open system. Openness in the 3GPP standardization has been extremely important. So we work a lot with the chipset vendors. But in the end, smartphones are consumer electronics. And people select those devices not on their RF capabilities, but on the brand name or the look and feel or many other reasons to select a smartphone. I think it's important that with fixed wireless access we're going back to this complete ecosystem where we do not only manage the networks, but where we also have control over the CPEs. So this is why we started or revived the partnerships there with a number of parties. With Netcom Wireless, we're, for instance, building this NBN in Australia. A lot of experience there. Yeah. So, Peter, maybe you can say a few things.
Okay, so one of the fundamental differences between a mobile network and a fixed network today is where that demarcation point is for the network. So in a fixed network, we bring the network all the way into the home, and we have a box. That's the end of the network. In a mobile, you're all carrying mobiles in your pockets. That's your mobile. It's not the operator's mobile. You're in control of the software, which apps you want to do, upgrades. And you accept that you might walk into a room or into a basement of a car park and not have coverage. You may not like it, but you accept it. Okay? In a fixed world, if you lose service, you're unhappy. End of story. Yeah? Because it's managed in a different way. So what we need to do is we need to change. If we go into a fixed world with fixed wireless, we need to change that whole process. The whole we need to look at it at the subscription in a different way as well. So if you're a fixed user, you expect reliability. Now, typically, everybody focuses on about speeds and 100 megs or 200 megs or whatever, but actually you want reliability. You want the DNS server to be up. You want the latency to be consistent, preferably low. You know, there's lots of services on top of the basic access that need to be in place and always in place that you can rely on. Yes, the speed is important. Uplink just as much is important. Typically we forget about that. And latency, again, needs to come down. If we want people to now use cellular technology for fixed access, then gamers and other sorts of users now need to use the cellular network. And latency for them is a key thing. So, and this is some of the things that we're driving in the move to 5G. But we need to bring that demarcation into the home. So the device now needs to be a managed device. It needs to have the remote support, diagnostics. In the fixed world, we now have all these rules about having to manage SLAs, minimum speed guarantees, etc. We need to be able to do that in the cellular world as well. So a lot of focus now on the CPS units. So then, like I said, we bring now the trusted zone to the house. Now, it could be the roof of the house or inside the house, but we now engineer and manage that radio link. Of course, once you're in the home, the Wi-Fi is then still the big grey area, which people still credit the responsibility towards the ISP when it's not. But at least we can then manage the performance of that radio link into the home. So, if we look in the industry today, there are typically two sorts of fixed wireless access device. There's the outdoor high-performing antenna. These are great for rural, going on your roof. Needs an engineer to install it, typical like a TV aerial engineer. Really, really high performing. If your mobile phone, you have to stand by the window to make a call in your house, this will pick it up. This will work well. Yeah? Of course, if you're in the middle of nowhere, the Sahara Desert, and you've got no mobile network at all, it might have a problem. But if there is a signal, these will pick it up. And of course, this would then interwork with your existing gateway hub, BT Home hub, or Virgin Media Box, or whatever. It's just another access point. The other solution that's on the industry today is this basic all-in-one indoor router box. Essentially, it's the hub with a modem inside it. Okay? It's nice. It's delivered in the post, the user self-installs it. But like your mobile phone, it's sitting inside the house, perhaps surrounded, people put routers in the cupboards, or on a bookcase, you've got furniture losses, you've still got to get through your energy efficient double glazing. Yeah? So it's cheap to deploy, but it's low performing. And that's the big difference then when we look at these sorts of solutions. If you really want an engineered solution, high performing, then we can get high gain products, put them high up on the house, line of sight, or, like I said, we can go the opposite way around. So it's this people are doing the pros and cons. We have a lot of operators who focus on quick, get to market, all in one indoors, but then they find that, okay, maybe 70% of the users are addressed, and then they have to then look at other higher performing solutions. From a network point of view, if we start talking about fixed wireless access being a wider deployed solution, we need to look at the network efficiency. So here, really the drive is you want the least amount of load on your network. You want to get the most capacity out of your spectrum asset as possible. So here, this is where the RF performance of the outdoor really starts to sell itself. But where is the industry going? Well, you know, what if we could have the performance of outdoor but the cost of the indoor? The self-install ability of the indoor, etc. So we've got to add in all the 5G stuff as well. There's a lot of stuff that's happening in the industry. So the next step in the industry, and this is not Necom, this is all CPU vendors, is bringing these two worlds together. So if you do Google searches, etc., you'll see a lot of focus on through glass data and power. So for instance, a user could install his own device on the outside of his house by putting his hand through the window, clipping on a unit with another magnet on the inside of the window, and hence his modem is outside the house. But there was no engineer to install it. So all these sorts of solutions are being looked at. So this will be the next wave that'll come, together with 5G, because millimeter wave is not going to get through your windows very easily. So we have to look at those sorts of higher performing solutions. But you can't stick one of these on your flat in the centre of London. Yeah? So it has to be in a different sort of solution. So you want millimeter wave in central London, but you can't have one of those. So there's a lot of stuff going on in the CPU market.
Thank you for that. Although there's a lot of stuff going on, it sounds fairly easy, and I think there's a lot of spectrum already in those networks to maybe create those offerings. What is then the hurdles? What is the discussions we see with the MNOs that want to go into fixed wireless access? One of the learnings is that it is another access strategy, an access technology. Does it mean that the core network is entirely ready for this? Of course, the DOCSIS and the copper networks, they have specific features, capabilities that are utilized by those TV and service solutions in top. Things like Ethernet multicast or maybe the linear TV distribution over DVP. Those are things that not automatically run well on a fixed wireless access connection, which is basically a unicast connection. Of course, the developments in this space help. We get better codecs. We start to see much more on demand. So traffic becomes more and more unicast anyway. So over time, actually, we will see that the situation improves. But of course, this creates a hurdle when you start to look at your addressable market as a fixed operator, and you start to think about can fixed wireless access now solve, let's say, the last 10%. It will require some rethinking of what's happening in the service layer domain, as it is not truly service agnostic today. It's also another department, typically. Is this fixed guys trying to build mobile networks, or it's a mobile department that has to offer a fixed service proposition on top, which is quite new. These guys, they offer data plans that go straight into the internet. Technology-wise, it's not that difficult. There is a clear separation, I think. It's about those edge functions like the BNG in a fixed network, which would then be similarly a packet core network element in a fixed wireless access network. But there is a bit of work here, and there is a few hurdles in organizations and in the overall solution to be taken care of. It's also interesting that if you have very high bandwidth offerings today in the fixed access, whether the CMO department is willing to say, I'm going to create a second proposition, because that's based on fixed wireless access and it has a bit different limitations and capabilities. At the same time, we see there's one example now in the Netherlands with Delta GreenNet. These guys are putting up a proposition greenfield for small villages, and they actually managed to get a much higher ARPU out of the underserved, because there is a real need out there and there's nothing else. So basically they sign up for more money for less bandwidth than in the fixed offerings that is available in the urban areas. Okay, what did we do? We have done a study where we looked at, it's our consulting colleagues, they looked into Test Valley, where is a number of villages, hamlets that are underserved today, apparently. We got input from quite some operators in the UK. That has been reworked into that model, and then we tried to see how much, how the TCO model for such a network would look like. What we've done is we've looked at that area, and we saw that it's basically 12 local market areas depicted here by the squares, where you will find a significant number of potential customers. The number of households are here in this overview. And then we started to model. Let's take a number of assumptions. On the market, household density, the share that you could potentially address, churn, that kind of things. We compared it to the assumptions that are generally accepted in the market for a fiber deployment there, and then we started to compare a little bit how these two would compare. If you do that, you see also that the way we model and we do investment decisions on mobile networks are completely different than they are maybe on a fiber implementation. That could be local initiatives, maybe book value of fiber is 10, 20 plus years or so. Mobile networks, much more active equipment, spectrum discussions behind it. Is it shared spectrum or not? So it's not an apple-to-apple comparison. It's not that straightforward. But anyway, I think with the input given, we've tried to dimension it for the same type of service levels. So both data plans and video plans. In the video plans, obviously, we take a bit higher data rate, but also we take a much higher simultaneous usage of the service. With internet offerings, you can do quite a little bit of statistical overbooking, whereas with video services, you have to take much more conservative approach. So what we saw, it's those 12 markets on the picture. It's basically, there's two really close together actually that we could initially serve by one site. So it adds up to 11 sites that we would need. And a site you should think about 18-meter pole. So it's not really the cellular grid that tries to build nationwide coverage. It's typically lower poles, a bit closer to the community, and then pointing in a kind of 90-degree angle towards such a community. Doing that, I think we can do this with 11 sites, with the assumptions on the previous slide, 40% utilization of all those households connected in those villages. And the thing, and that's maybe nice about mobile, with fiber you have all this pre-investment, so you have to go past by all the houses, and then there's a drop cost when a house connects, but the majority of the money has already been spent in the initial fiber digging. With mobile, we can upgrade the site, we can add another site over time, or we can add more spectrum to the site when it's available, and when there's a need. So what we've done in the modeling is basically that we've shown here the total capacity that was built for such a site, 30 gigabit per second here, and then with the uptake, subscribers coming onto the network, households being connected, we can actually see that we reach that capacity, and then we can do another investment. In this case, this would be 2023 or so, when we have to start densifying the sites and create more capacity. So you can load these networks nicely to approximately 90% or so, well in advance. It's predictable. Fixed wireless access is much more predictable than maybe the mobile industry is. Sometimes new app comes on and or data plan changes, competition does something weird with unlimited data plan. All of a sudden you see a huge peak in data traffic, and you have to cater for that in your mobile network. In fixed, it's much more stable and predictable. If you do that, then basically you see this. This is in pounds. This is cost per household passed, basically. And then this is a cost per household connected, where we compare fiber on both sides to two types of fixed wireless access. One is on 3.5 gigahertz. It would be this type of equipment. It would be predominantly 4G based in the early years. With the arrival of 5G technology, the whole TCO will shift a few years as it's two years down the road basically. But with millimeter wave, we see that due to this massive amount of spectrum that will be available, the case actually further improves. This is the network side of things, if you like. So it's half if you would build on fixed wireless access compared to a fiber deployment. If you add the CPE cost, then the difference percentage-wise goes down a little bit because there's also a bit of CPE work there with the fixed wireless access network, obviously. We saw the outdoor installation. We've been very conservative. This is £1,800 for CPEs over a period of 10 years. We have assumed here 2 times replacement of the CPE throughout this 10-year life cycle, and it is way too much. Technologically, this thing can survive for 6-7 years, I guess.
There are networks in place today, 7 years running quite happily.
We've tried to be a bit conservative, I guess, here. There's also churn involved when people leave the service for whatever reason, then you might have to take it away from the rooftop again, and there's an additional cost, etc. Of course, the case improves even more when you take into consideration that you can spread the investments. What we see here is we created a net present value overview of the costs, especially since the densification of the sites, half of the installation cost actually will go to this year number 7, year number 8 of the service. And when you do it, you know that there's actually also a revenue and income guaranteed behind it because it's triggered by the capacity and the usage of the network. There is much more behind this also when it comes to the data plans and let's say the income. So the total profit and loss overview has also been prepared. I didn't want to show because it goes into an awful lot of assumptions when it comes to how to address the market. There's many flavors of that. And in my view, it also very much depends on whether you're able to build this maybe on top of a mobile network. So reusing this underdeployed spectrum, or whether this is a complete greenfield opportunity, because then you will come with a different service offering as well. So I've skipped that part. When you compare this to pictures that we made like 5 years ago for LTE, it looks much, much better. And I think this is showing that fixed wireless access is picking up momentum thanks to, maybe going to a summary slide, that's next. But mainly thanks to the fact that there is so much additional bandwidth now at a much lower cost per bit. I said I would go back to Verizon case a bit. This is the one. They are building these types of towers, so nicely camouflaged green pointing into the neighborhood, 18 meters. Verizon is testing millimeter wave, so they have a pre-5G standard solution. And what they see in those suburban communities is speeds up to 1 gigabit. So that is basically this wireless fiber segment that I talked about before. There's a lot of learnings, line of sight, non-line of sight, foliage. We don't have a good experience with millimeter wave, and it truly behaves different than the cellular frequencies that we're used to. Millimeter wave used for microwave is known, but it's line of sight connections. And now we start to use this in all kinds of directions, and there's homes that maybe work through reflections. But still, the outcome is really promising. 600 meters, we still see up to 1 gigabit of speed. And actually the interesting part is if you get it, it's because there is a line of sight. If you don't get it at 600 meters, there's no line of sight. So this part where it degrades basically is no longer there. Interesting case also, and this is also a discussion in the UK. I know that in London also fiber deployment is very tricky. It's very difficult to go into the buildings, to dig the roads open. This apartment complex to apartment complex, this case is working really well, and that ties into your discussion about how do the CPEs develop. if you can't get here with fiber, or if there is a fiber here, but you can't distribute it well into such a multi-dwelling unit, into an apartment complex, it's quite interesting to look at millimeter wave as a means with beamforming to actually address this whole grid of apartments, if you like, across the street. And this is where we see these true glass solutions. So small panel antenna on the outside, which is then connected on the other side through the glass, stitched together, and then gives you the outdoor performance with a self-install mechanism. Verizon will now succeed. Commercial offerings start second half this year in 2 cities. Sacramento will go first, and next year they have a quite big rollout scheme. They're very vocal about it. So if you go on YouTube and Google Verizon millimeter wave, you'll find loads of videos. Very nice insight. So yeah, very promising. But I would say these guys are 2 years ahead of Europe when it comes to millimeter wave. We are facing now the first discussions about 3.5 gigahertz. That spectrum discussion will go first. This is where the MNOs will focus. This is where fixed operators might want to focus. And then millimeter wave is expected a bit 2020 in West Europe. So, summarizing all this, fixed wireless access is gaining momentum, it's becoming more attractive, but there's a lot of actually drivers that influence the decision. What are the offerings? What is the availability of fiber today? What options do you have? Of course. As the business case works differently, also what is the market dynamics? Is there a willingness to pay? Is the operator also willing to actually create offerings for a relatively small segment in the market? How are you as a potential service provider then maybe also equipped with spectrum capability to work with an MNO, or maybe you are a fixed mobile converged operator, so what's the option? Can you also divest part of the investments to, or focus the investments on suburban areas? I think with 5G coming up, a lot of focus will be on dense urban first. So these two kind of need to balance each other out. Yeah, that's about it, I think. With that, maybe questions? Yes.
You showed ARPU figures there for the basis of the model. How sensitive is it to the ARPU expectations?
The few examples that are out there right now show that there's a willingness to pay more ARPU, but those examples have been built in areas where there is no reasonable alternative.
Yeah.
So there's a real need, and then higher ARPU is basically accepted. This startup has ARPU value 80 euros, and they sign up quite a lot of households today. But they are addressing this scarcity.
They're addressing I don't know what the percentages of off the cable or DSL plant or fibre is in the Netherlands. So I know
it's a small segment. It's a very small segment. I think we're quite fibre rich in the Netherlands, and also DSL are quite good quality.
Despite what people say, the connectivity is quite rich here, considering 95% of the homes passed today are covered by 10 meg or more.
Yeah, so it depends. Is there a willingness to really go into that 5%, and then even it's probably a percentage of a percentage. And if it requires maybe adoption of or adaptation of your services on top, that's a little bit, I think, where the discussion is around. Will there be fiber in the near future? Yeah, that of course helps to make a decision on whether or not to deploy fixed wireless access. What we do see is that maybe where fixed operators do not want to play, mobile operators say, yeah, but I've got all this extra capacity in the network anyway. I'm going to offer kind of an unlimited bundle and an unlimited data plan with a nice device that comes with it, and I'm going to address these customers. It's typically more data services rather than maybe TV offerings, but with OTT TV platforms, of course, that kind of comes automatically as a next step. So it might be a third competitor next to the cable and the fiber companies.
Perhaps it's also worthwhile mentioning, when we look at this connect the unconnected type case, then this is a POTS replacement as well. So when we start talking about the ARPU levels, it's your line rentals, etc. And we've seen a lot of markets actually where the driver is voice, and I can do broadband at the same time. Hey, that's a nice thing. So, but it's actually about turning off copper in far to reach places.
Okay.
I was going to ask if there's any data on how millimetre waves cope with rain and snow.
Yeah, I might have some of that. It is affected. It affects, and speeds will go down. But then again, we have a lot of new modulation schemes in place now, so we also have a lot of means to deal with it. Service levels will degrade, of course.
It doesn't kill it then? You get
it depends on what you're trying to build, I guess. Internet services will survive quite well, and for a long time. And with Verizon, they've looked into this extensively as well. They've been positively surprised, but yes, there is an effect. Then again, if you're going into gigabit speed to a home, then when do you get an unhappy customer? You can probably have quite a bit of service degradation. And you need to look into maybe some prioritization of service levels within that radio bearer. So control planes should survive, and then user planes you might want to prioritize services a little bit like inside the copper networks, I guess, today. So that's happening as well.
What kind of latencies are you achieving over the network?
Yeah, it's a bit difficult to answer in the sense that so with 3G, 4G we sit at 30 milliseconds or so. 5G radio network should go down drastically, but there needs to be a complete overhaul of the packet core still. Standardization is ongoing. 5G radio standard, single radio path should be a millisecond. This is where it comes out of the radio base station baseband. Then it needs to go into the packet core, which will add milliseconds. But that would be similar to maybe layer 3 routing functions in a fixed network. So dramatic decrease. If you look at, for instance, this machine type communication use case, which I showed on the first slide, for automotive and so on, there's kind of an ambition to go sub 5 millisecond single path. But of course, this packet core sits somewhere in the network, so this is where edge compute comes in and where we start to move user plane functions closer to the base station or in the base station. So that's a multitude of aspects to decrease. But that's a bit, the dot at the horizon basically right now.
Or when you showed the converged architecture. So in a fixed wireless world, if you're doing a lot of it and you're a fixed operator, it'd be best to start pushing your mobile data, your fixed wireless mobile data, to the same locations as your BNGs, etc., and get it peered as fast as humanly possible. So,
sorry, BNG?
Your border network gateway. So whatever, it depends what sort of fixed operator you are. But putting it in the same infrastructure you've got in your fixed network, as opposed to today in a mobile network, everything is centralized in a couple of data centers in the country, because the amount of data is it's about a 20th of what's in the fixed network. So you've got to re-engineer the way you look at mobile. But only the fixed wireless slice of mobile. The rest of the mobile can still be handled in the same way. And even on latency, even LTE is coming down latency. So we can do down to 10 milliseconds on LTE on the radio. So it's a lot of work going on.
In the study you did in the test valley, I think you wanted about a dozen new base stations.
Yes.
I may have missed it, but how are you planning to interconnect those with the backhaul? Were you going to use fiber or
that will be a fiber
radio links?
Yeah, and that fiber needs to be there. And we've looked into alternatives, so microwave can overcome short distances now, and we go up to 10 gigabit, which would be a fair backhaul solution for short distances. But it's just kind of maybe a problem solver for difficult areas. So there needs to be a fairly amount of digging for that fiber to those base stations, correct. Sometimes there is these hurdles like directional drilling under a railway or a river, or that could be overcome by microwave, but essentially it's fiber. Yeah.
A lot of this is around the size of the cell that you can deliver that bandwidth to.
Yeah.
What's the smallest cell size you can have for dealing with dense populations, for example?
The smallest.
I'm talking about here, you're talking about 10 gig. Say you've got 10 gig and you want to deliver, that's 10 houses to give a full uncontended
gig,
1 gig.
Yeah.
10 houses is, what is the physically, in terms of the space, in terms of the shared bandwidth, in terms of the shared spectrum?
Yeah, so smallest, I think we see small cells now available for 4G that could serve just a couple of households. They could do maybe, what could they do? That could be a 1 gigabit connection, typically, and that could sit behind a microwave. And that 1 gigabit, if you think of a service offering of maybe 40, 50 megabits, you could do still small hamlet of 20 households or so. You could still have a very effective service. That would be 5 watts output power or so, which will give you a few hundred meters. Anything closer, I think that reduces so much also the distance between the radio and the household that it's questionable whether you're really solving a problem. You might as well have a fixed connection then in place. So maybe that could be an answer to the question.
I think these questions are more about whether fixed wireless could be a replacement even in connected areas, or whether it is always the fact that a fixed connection is better.
Yeah, and I think this is what Verizon is looking at also in more dense urban areas where you have fiber in one street, but you don't want to dig open that street and go in all the side streets. And this is where you could do light pole with millimeter wave, and then you could have maybe a few hundred meters of distance, and then you could have fairly good amount of service levels to all those houses connected. That's really millimeter wave discussion.
Okay. I think it just comes down to the fact that the UK and particularly the Netherlands are very dense population centres compared to the US.
Yeah.
Or large parts of the US.
Yeah, so what I've learned is from the discussions, especially in London, that it's just impractical. You can't get to those houses by digging and closing down roads, and apparently that is the major issues found in those fiber development programs. And millimeter wave certainly could be an option there, especially if you have access to the fiber in that space. If you make these cells smaller, you will get more cells. It's a dense area, so maybe every second street or so would have a light pole with a millimeter wave radio. It means that every second street also needs access to fiber for the backhaul of that.
Gentlemen, I'm afraid
we close it down.
We're out of time now. So it just remains for me to thank Jeroen. I'm sure you would like to as well. And colleague.